Hi guys, this is factoring by grouping. So today we're using a technique that's used for a polynomial that has 4 or more terms. Most of the time we'll see that something with like x to the third, or maybe we see some like crazy xy when you have a bunch of terms. So it's going to have 4 or more. And we're going to split the original polynomial in half. So it has to have an even number. So I'm going to take like this first section here and the second section there. So it has 2 sections. We're going to factor out a GCF from each side. So we're going to factor out whatever we can here. So for this first section here, I'm going to factor out an x squared. And what's left over is x plus 5. And then I'm going to factor out from the other side as well. So I can see that I can take a negative 2 out of there. And that's going to leave me with x plus 5. Right? I need to make sure that the leftovers are the same. So this leftover and that leftover have to be the same. So essentially what I'm going to do is put this and this together, x squared minus 2, and I'm factoring out. This is the same factor, that's what's left over, right there. So this is my answer for this problem. The reason that it's like this is because essentially you're taking an x plus 5 out of this one, and you're taking an x plus 5 out of that one. So that's like you're factoring out x plus 5 as a GCF, and then what's left over, the x squared and the minus 2, that's like the leftover. So really it's kind of like backwards from how we've written it in the past. The leftovers are here, and then this is the GCF. It's just like a more complicated GCF than it was before. So we can try number 2. So for number 2, I'm going to look at the first 2 here. I can see that an a can come out, and I should have a plus 3y is left over. And then on the second one, I can see that they're both divisible by 2, and they both have 2 y's in them. So y squared can be there. From there, what's left over would be an a plus, this is divided by 2 is 3, and there's 1y left over. So I can see that what I'm factoring out is this a plus 3y. And what's left over is a plus 2y squared. So that's my answer there. When I'm looking at number 3, the same thing. Why don't you guys go ahead and try this one on your own. Let me know if you have any questions. So if you're not listening, try this. Right. And then for this one, I can see that I can take a 2x to the second out. Left over would be just x plus 5. For this one, I have a 3x plus 5 coming out as well. So as you can see, guys, very similar to all of these problems, right? Just like that. These ones create this guy, the GCF, and then these are the leftovers here. From there, if you have something that looks like this, you're just still going to split it into 2 sections. So you have like this section here and that section there. You're going to look for things that are in common with all 3 of these things. So I can see with 8, 4, and 4, there's a 4 in common, and they each have an x. So I'm going to take the x out as well. What I'm left with is 2 a's, because 8 divided by 4 would be 2, with the a, plus just this b is left over, plus just this c is left over. From here, I can see that they all have a 3 in common, and they all have a y in common. I have a y here, and what's left over, divide this by 2 or by 3 would be a 2. Still, there's an a there. There's a b in that second term, and a c. So here's the a, the b, and the c. And I can see this like quote unquote GCF, this thing that's in common for both of them is 2a plus b plus c. And then what's left over is the 4x plus 3y. Okay, so go ahead and try number 6. If you have any questions, let me know. Thanks, guys.